I won. Today we are going to discuss resistant heating. Earlier I told it is based on the IR effect, I square R effect. That is the power equation. When the current plays through the resistant, current IR loss take place which produce heat. IR losses take place which produce heat. There are two methods of resistant heating. Earlier I told that the power frequency heating, that the direct current, direct resistant heating. And today I am going to discuss about the direct current resistant heating and indirect resistant heating. Look at the picture. This is the furnace. This is the furnace. The furnace contains two electrodes and electric power supply can be enter to or supply this to terminal, and there is some charge, and this is the resistant powder. Resistant powder. This method, material or charge, this is the charge, to be treated as resistant and current pass through it. When the current pass through it, is the resistant powder, and the charge may be from powder. It's the powder. Small solid pieces or liquid. The two electrodes are inserted in the charge and connected to either AC or DC. This supply can be sometimes AC or DC. Then the two electrodes will be required for this purpose. DC single phase supply, for the single phase supply. But there would be three electrodes in the case of three phase supply. Three phase supply, when you are using three phase supply, insert three electrodes. When the charge in this form of small pieces, a powder is high resistivity material. Over the surface of the charge, avoid direct short circuit. It's a direct short circuit, this charge. Heat produced when the current passes through it. This is the current pass through it. That according to the supply frequency, that the power frequency when you are use 50 Hertz. Then the DC current, that the same direction, that is not be effect for the heating, because DC current also that according to the Ohm's law, then the power equation, that the I square R losses can be made. This method of heating has high efficiency. This is a very high efficiency because heat is produced in the charge itself. This is the furnace. Then the furnace get heat and you can do any industrial work for the for the uh, melting metals or other plastic material also can be done because heat can be controlled. This direct resistant heating furnace. You remember that the direct resistant heating. And second one, this is the indirect resistant heating. This B figure shows the indirect resistant heating. There is this is called jacket, or this is called jacket, and inside the jacket there is some cylinder there. This cylinder contain heating element. Then charge also contained in the jacket. This is charge. This is the cylinder. And in this method, heating electric current passed through a resistant element. Which place in an oven. We can call oven. Heat produced is proportional to I square R. For the power equation. Heat. I square losses in the heating element. The heat so produce delivered charge, either radiations. I earlier told there are three methods of heating will deliver. The two methods can be used: radiations, and the convections. By combination of two, this is the method. Sometimes resistant place cylinder which surrounded by the charge placed in the jacket. This arrangement provides uniform temperature. This can be arranged for the produce uniform temperature. Moreover, this told automatic temperature control can be provided for the and the module we can discuss what are the temperature control methods for the heating can be done for the thermistors and auto transformer. There are several methods for the temperature control. Then now you can remember this resistant wire or heating element. Heating element there are some requirements. What are the requirements? Number one, high specific resistance. When specific resistance of the material of the wire high, only short length of will be required. Then why can be that if the increasing the specific resistance, then the wire can be used shorter. Number two, high melting temperature, because this wire need to high temperature. For the example, for some more than 3000 degrees centigrade, for the some metals below melting. High temperature, it making temperature of heating element high, it is would be possible to obtain high operating temperature. It can be when melting temperature of heating element high, it is would be possible to obtain higher temperature. Possible to obtain higher temperature. And third one, low temperature coefficient. This one, heating element. In the case material has low temperature coefficient of resistor, there would be only small variation in the resistance over normal range of temperature. When the temperature going high, I can say the example for this one, for the filament bulb, there is a tungsten electrode, tungsten filament. That the tungsten filament have same quality because low temperature coefficient. If the temperature high, there is no temperature, no resistance variation. It is good element have. Then high oxidizing temperature, number 4. High positive temperature. That means that the melting point is very high. That the oxidization, that for the oxidation, you know that the oxidization, then the reach to oxygen and attack to the element. Oxidization temperature of heating element should be high in order in ensure long life. This element long life. Mechanical strength, that the material can be used as a coil when very hard material can do. The material heating element should be processed high mechanical strength it on. These are the qualities about the temperature. We can today we can summarize for the we are discussing about the two type of resistant heating, direct resistant heating and indirect resistant heating. You remember, please mention and draw and note down your notes for this one. Thank you very much.